Hello, we are Group 4 of 11C, and today we shall talk about Experiment 2. In this experiment, we had to go through 4 different stations in order to learn more on gas laws and how the gases in each law are related to each other. Station 1 is focused on pressure and volume. The process was to position the piston of a 20 ml syringe so that there would be a measured volume of trapped air inside of its barrel. We had to use the Logger Pro program on the computer that was provided and open the file 3A gases from the Advanced Chemistry with Veneer folder. This file allows us to collect pressure data from the gas pressure sensor using events with entry mode. For each pressure reading that we had to take with the keep button, this mode lets us enter volume value. Lastly, we had to measure the pressure of the air with the syringe at 5 ml, 10 ml, 15 ml, and 20 ml. After that, we had to collect and observe the data from the table.
Station 2 is focused on pressure and absolute temperature. Using the apparatus shown in Figure 2, you will place an Erlenmeyer flask containing an air sample in a water bath, and you will vary the temperature of the water bath. First, connect the gas pressure sensor to channel 1 and the temperature probe to channel 2. Then assemble the apparatus as shown in Figure 2. Be sure all fittings are airtight. Make sure the rubber stopper and flask neck are dry. Then twist and push hard on the rubber stopper to ensure a tight fit. Open the file 30B gases from the Advanced Chemistry with Veneer folder. This mode allows you to collect the data pair simultaneously from the gas pressure sensor and temperature probe by clicking on the keep button. Then, determine the initial temperature and collect 5 pressure data at 5 degrees Celsius increments. Collect and observe data from the table of the software.
Station 3 focuses on volume and temperature. We used an Erlenmeyer flask containing an air sample in a water bath with varied temperatures. We had to assemble the apparatus as shown in Figure 3. Then we had to open the file 3C gases from the Advanced Chemistry with Veneer folder. This file is set up to collect pressure and temperature data from the attached sensors using events with entry mode. This mode allows you to collect a data pair simultaneously from the gas pressure sensor and temperature probe by clicking on the button and entering a value from the volume. Even though the pressure readings will not be plotted in the graph versus temperature, it is important for pressure to be monitored so that it can be kept constant. After that, we had to collect volume data at several different temperatures to determine the initial temperature and collect 5 volume data at 5 Celsius increments.
Station 4 is focused on pressure and the number of moles. Ensure that the gas pressure sensor is plugged into channel 1 of the interface. Open the file 30D gases from the Advanced Chemistry with Veneer folder. This file allows you to collect data from the gas pressure sensor by clicking on the button and entering a value for the number of molecules. Collect pressure data with the several different numbers of molecules introduced into the system.
Here are our gathered data from the experiments.
To analyze our data, first we had to sketch a graph that describes the mathematical relationship between the two variables from each station. Then for each of the 4 parts of the experiment, we wrote an equation using the 2 variables and a proportionately constant k.
Here are the relationships between the gas properties of each of the 4 stations. We then calculate the constant x for each of the 4 gas laws that were tested on.
Based on the mathematical relationship and equation that you obtained in step 1 above for each part of the experiment, combine all 4 variables into a final equation. This combined equation will contain P, pressure, T, temperature, V, volume, and N, number of moles, as well as a new proportionality constant K.
Overall, the experiment went great. There were some problems encountered during the setups, but eventually the system worked and we were able to collect data as normal. Here is an application of gas laws in real life. Let's say you're in the 3rd floor of a building and it's really hot and you'd like to be able to lower your temperature. The higher you are in the area, the higher the pressure. Therefore, the temperature will also be as high as it. So if you'd like to be able to lower your temperature, just go down a couple of floors and your pressure would decrease, thus making the area much colder. This is an application of the Gay-Lussac's law where pressure and temperature is directly proportional. So if one thing goes up, the other follows.
The Lawsonian core value that we can relate to this experiment is cares for the earth, because an example of this would be that toxic gases such as carbon dioxide can change the temperature and make it increase, which can result into climate change or global warming.